In topic 2.1, we will be analyzing relations and functions. A relation is just a set of ordered pairs or an equation. So here we have negative 2, 4, negative 1, 5, 0, 6. That's a set of ordered pairs. Y equals 5x minus 1 and f of x equals 2x plus 3 are your equations. So those are examples of relations in math. A function is a specific relation where each element of the domain is paired with exactly one element of the range. Your domain are your set of x values, your range are your set of y values. So in other words, and you might have heard this when you were younger, the phrase x cannot repeat. So to see if something's a function, x cannot repeat. Here are some sample problems. We're going to be finding the domain and range of each one, and then we're going to be determining if it's a function or not. So in example 1, we're going to start by finding the domain. That's our set of x values. So I'm going to look at my x's. 4, 0, negative 9, negative 7, and 7. Next, I'm going to do my range. Remember, range is your set of y values. So the y values here would be negative 9, 4, 3, and 9. Notice how one of them repeated. When you're making your list, you don't have to put a number more than once. So if I already put negative 9, I'm not going to put it a second time. So I'm going to put negative 9, 4, 3, and 9. And then the question wanted to know if this is a function or not. So remember, the rule for it to be a function is x cannot repeat. Since all the x's here were different numbers, 4, 0, negative 9, negative 7, and 7, none of them repeated. So this one is a function. Now, it's okay that the y repeated. When you're talking about function or not, it's only the x or the domain values that matter. So on number 2, we're finding our domain. We have negative 6, 6, negative 3, 9, and 9 repeats. So I'm not going to write it more than once. I'm just going to write it once. But I already know, since my x repeats, that this one's not going to be a function. So right away I can come down, and when I'm answering if it's a function or not, the answer is no. And that's because x repeats. We also want to state our range or our y values. So here our y values are 6, negative 4, negative 5, 9, and negative 2. Question 3 and 4 give function maps. So when you have your mappings, domain and range are really easy because your domains or your x's are already in one side, your range or y's are already in another. So here my domain is 3, 6, 8, 9. My range would be 0, 4, 6, 7, 9. And to see if it's a function, you want to make sure x does not repeat. So if you look at our x's, this really represents 3, 0. This one here represents 6, 4. Then we have 8 pointing to 7. Then we have 9 pointing to 4. But 9 is also pointing to 6. So you'll notice the 9 repeats. So this one is not a function. On our next mapping for our domain, we have 0, 5, 7, 8, 9. For our range, we have 0, 4, 8, 9. And we want to check if this one's a function or not. So we have 0, 0, 5, 8, 7, 9, 8's also pointing to 9, and 9 is pointing to 8. If you look, all these x's are only pointing to one y value, so they're all different, so none of them repeat. So this one is a function. Again, because all the x values there only go with one y value. We have 0, 5, 7, 8, 9. None of them repeat. When you're looking at a graph, to find the domain, you want to look at your x values. And I always look from left to right, because you want to go from lowest to highest. So if you have a scatter plot, like in question 5, you need to look at every single x value. So here I have -4. Then I have -2. Notice how I'm drawing a line to the x. I call this take it to the x. Then I have 0, 3, and 4. So those would be my domain or my x values. Next, I'm going to do my range. For my range, I go from bottom to top, because you want to go from low to high, and you're going to take it to the y, because you're using your y values. So on the bottom, I have -4. Then I have both of these points here at -2. Then I have a point at +2 and a point at +3. So when you're doing domain, take it to the x, left to right. For range, take it to the y, bottom to top. To check if it's a function, when you have a graph, you do something called your vertical line test. In other words, I'm going to draw a vertical line, and it can only cross through every point once. If it crosses through 2 points, it's not a function. So here, if I do a vertical line here, 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 and here, they only cross once. So this one is a function because none of the x's repeated. Here on this next one, we're going to do domain. Again, you look from left to right, but this time it's not a scatter plot. So you just look at the very left and the very right and take it to the x. So here, this first one's at -4 on the left and 5 on the right. So I'm using my x values right now. We're going to write this how we did the compound inequalities, where we use number less than x less than number. So my domain would be -4 is less than x is less than 5. And since the 5 had a shaded circle, it needs the little equal to sign. Next, we're going to do range. For range, you look from bottom to top, and you use your y. So my bottom is at -4, and my top is at 6. This time, use your y. So it's -4 is less than y is less than 6. Since the top one was shaded, I'm going to use my equal to with the 6. And we want to know if this is a function or not. If I do my vertical line test, it only crosses once, so it's a function. I'm going to go a little faster on the next one. So here for domain, again, we look left to right. So on the left, I take it to the x. It's at -6. Then you go to the very right. On the very right, it goes all the way to +8. So very left, very right. So I would put -6 is less than x is less than 8. Both of these get the equal to, because technically everything on this curve is shaded. The only time you don't put the equal to is if you have an unshaded circle on your graph. But here, since everything was technically shaded or continuous, you use equal to. For my range, I look from very bottom to very top. So the very bottom is here at -7, and the very top is up here at 6. For range, make sure you use the letter y. Again, both of these get the equal to, because everything on this curve was shaded. There was no unshaded circles here. I'm going to check if this is a function. So again, for it to be a function, you do your vertical line test. Here, if I do a vertical line, it crosses more than once. So that means x repeats. So this one is not a function. If you look at our last graph, this one's a little different. Here, when we do domain, we look left to right. But if you look at the left, it has an arrow, and the right has an arrow. That means it's going to keep going, left and right. If it keeps going, then it actually contains every number. So for that, you would say all real numbers. For my range, I'm going to look low to high. But the same thing happens here. It's going to keep going down. It's going to keep going up. So since it's going to keep going, the range is also all real numbers. And then the last thing we're going to answer is if it's a function. Well, if I do a vertical line test anywhere, it only crosses once. Since it only crosses once, x does not repeat. So this one is a function. So, okay, for domain, when you're looking at your graphs, left to right, take it to the x. For range, you look bottom to high, take it to the y.